Hello, and a warm welcome to all the participants. On behalf of Chebrolo Hanmaya Institute of Pharmaceutical Sciences, I wholeheartedly invite and wish a very good morning to all the participants. Yesterday, we started a national webinar on the importance of statistics in the field of pharmacy, which is chaired by Professor L.D. Patil. This is a two-day webinar, and today we will continue the session with from where we have stopped yesterday. So I think all the participants had their basics brushed up, and whatever was discussed yesterday was revised thoroughly. Now I request Dr. L.D. Patil to please take over the platform and continue from where he has left yesterday. Sir, over to you.
Okay, good morning. Thank you, sir. Okay, so I'm sharing my screen and starting it.
Yes, sir.
Is it visible?
Yes, sir. Visible.
Voice is okay?
Yes, sir.
Volume is okay?
Yes, sir.
Yeah, okay. So I'm starting, sir.
Yes, sir. Please.
Good morning, dear participants. I think you may have done some homework, what I told you. Summarizing the things, we are studying biostats in pharmaceutical part. And what yesterday we studied, that was a totally introductions. I have given one or two examples in Z test and in T test also. We've seen what is statistic, what is biostatistics, what is a descriptive statistics, what is IS, what are the parameters of both, which important attributes we are taking in both, we are studying in both. Then we've seen what is normal distribution or Z distribution. I given one homework that you should plot the histogram. You must have your own data and plot it and see the nature, whether it satisfies that 5 conditions of the normal distribution or Z distribution. That is one cluster unit model, symmetry, no up and down. There should be steadily up and down with a one cluster. Then two important things, that is mean plus minus one standard deviation. 68% data should be in that range. And second, mean plus minus 2 standard deviation. So that were the conditions for normal distribution. Then what is the parametric and what is non-parametric test or parameters? Then we seen some graphs, some tables, sorry, not graphs, tables, Z table, that is area table, then T table, and then ANOVA table and chi-square table. You may get in-depth knowledge if you have some practice. If you read it, it will not be possible, but you have to do by your own. So how F or ANOVA table is used, etc., etc. Then we studied Z test, who is the innovator of Z, that we also said. Simple formula, Z is equal to x bar minus mu upon standard deviation upon root of n. It was very easy. We calculated one or two examples on Z test and pi also. Then we shifted on T test. T test is for mean only, difference of mean. it was measuring the differences in the mean. And again, T and Z are resembling, they are somewhat similar. The difference is in terms of number of samples. If n is greater than or equal to 30, then Z is less than, etc. We studied. And examples, first, grid of in the capacity is 1 gram, the capsule being 1 gram. Take
Yes, I disconnected. Sir, please unmute yourself. Sir, you're on mute, sir. Please remove that.
okay. Yes, is it okay?
Yes, sir.
Now sharing option also, again in sharing, host disable participants screen sharing. So please enable me.
Okay, sir. Just a minute.
I was disconnected, so it may be.
Yes, sir. I understand. I understand. Just a minute, sir.
Yes. No. Yes, now it okay. Yes, thank you. Is it okay? Hello? 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 Do you hear me? Okay.
Yes, sir. Please continue, sir.
Yes, yes. So now uh, that was the last example what we taken. Now we are discussing second example thoroughly and how to calculate using Excel or any other software that we go uh, by screenshots and live if possible, if network permits us. The example, this is an important example, and those who are doing PhD or PG, please kindly have your attention here. A tablet formulation was developed by F&D unit with T50, that is time to dissolve 50% of the drug was 126. So that was the mu. It is hypothetical that the T50 time of the developed formulation is 126. So mu is 126. And that formula was given to the production department and batch was prepared and it was examined for 10 times. So 10 tablets were taken and its T50 time to dissolve 50% of the drug was measured and tabulated as shown in the table. So here, first tablet 157, second 121, and 10th 148. So these are our data. Question is, can it be forecasted that the production unit has prepared the batch with required standard, or is there any production problem? Does it meet the standard, expected standard, or does the results are significant or non-significant? So we are performing one sample t-test. The sample is T50 data and N is 10. So sample size is 10. Number of sample 10. The T50 data of 10 sample is given in the table. And hypothetical, that is total population mean, the machine or not machine, the formulation shows average 126-minute dissolution, T50 data, minutes. Is it reliable? So I calculated xi square, then difference in x from xi square, difference in x, and difference in x means xi minus x bar. X bar we calculated by summing up all the 10. Just a minute, I have to take that pen. Just 1 minute, please. So we calculated xi square means square of 157 and so on and sum of that. Similarly, we calculated mean by summing up all results divided by the number of results. So x bar is 138.3. Xi square is 1,93,551. Then dx is xi minus x bar difference, and sum of that sigma dx that comes to 0. So results are adjusted results. Dx square of the difference of xi minus x, and sum of that comes to 2282. So these are the calculated data. Okay, now yes, then we calculated escape by formula dx square divided by n minus 1 whole root. And from that we calculated SCX that comes to 5.0359. Then we use TCal formula. So calculation of T value by x bar minus mu upon SCX, and that comes to 2.44. Then looking into the table, we get the T table value 2.262. Now here 2.262 is less than 2.44. So TCal is greater than 2 TTAB, means there is significance difference. So HO is not accepted, it is rejected. Hence, there is problem in scale-up devices at the manufacturing level. So from TCal and TTAB, we did it. So we calculated the everything. Now, I'm using simple Excel file. This is a simple Excel sheet. I pasted the table. I pasted the table. Yes. Yes. Can you see the Excel file? Hello? Yes, any participant, please say, can you see the Excel file? Yes. Yes, thank you, Venkata.
Yeah. Yes, sir. Visible, sir.
Yes. So now I pasted that data of that. So serial number one, first tablet, second tablet, and so on, 157 and so on. I calculated average. In the formula is, what is the formula of average? Sum of the data divided by 10. And if we go in the Excel, we are getting this. So how to do that? Let's see here just now. So formula, click on formula, go on more functions, click on statistics, and click on average. Click on average. Select the data. So I selected that data from this much. Okay. And then click OK. Our answer is 138.3. And that answer I got here. So this is a simple Excel file. Similarly, I calculated standard deviation. Same method. Click on formula, click on more functions, click on statistics, keep your cursor and go at STD. Now there are so many. You see, there are STDVV, ST this. So which is to be taken? Which is to be taken? We have to take STDV. Where is it? Here is it. Why it is not here? Something is wrong with. So I calculated by using that, and just now I'm not getting it. Something is wrong with my part. Standard deviation. It's not there. STDVA. No. Let's take STDVA. What happens? Yes, it will be same. So here, take the data and just a minute. I have to put my cursor here, otherwise it may remove the old value. So this STDVA here, select the data, click on OK. So same answer we are getting. So use STDVA. Actually, generally it is STDVA here just now, but here it is STDVA. So something is wrong with that. The number of N is number of samples, that is 10. Now standard error of X. Standard error of X is equal to standard deviation divided by root of N. So I written standard deviation divided by root of N. So N raised to 0.5. And that comes to 5.6. Then I calculated T. T is equal to mean minus expected divided by SEX. And that comes to 2.44. And same value we got in that table. So this is the paste of that part. So these are the functions. If you see, sorry, just a minute. I have to. Yes. So these are the functions. If we write equal to, then it becomes functions. Otherwise, it will not be. So if we write equal to, this cell will take it, but in Word, so this is our functions. Similarly, standard deviation, that is our second functions. This is our third function, that is SEX, and this is our actual calculate value. So using simple Excel, we can calculate T44, 2.44. From T tab, we seen the values and then we conclude it. So it comes almost with a point, with decimal point same. Okay. Again, if we go with the previous, we are getting same answer by calculations. Then I used Minitab also. We can use Excel also, but we use Excel for just calculations. Similarly, we can use Minitab. Minitab is very versatile software. So install the Minitab 18, open Minitab. I written that steps in a blue color fonts. So open the Minitab, paste the table like this. Like this, you paste the table in that sheet. We'll see just now. Then click on stats, then click on basic statistics, then click on one sample t-test. This is a one sample t-test. And this is the, when we click on one sample t-test, we get this menu box, dialog box. where we have to write, we have to select the data. How to select, that's an important thing. And then click on OK. We'll get this output. We'll get these outputs. So let's see. I kept it ready, just I'm ending it. I'm opening the Excel, sorry, Minitab. It may take 1 or 2 minutes. Meanwhile, hello, can you see the Minitab files? So I
Yes, sir.
pasted,
Yes,
I
sir.
pasted the data in the Excel sheet. That 10 data I pasted it. Okay. From X file, I copied it and here I pasted it. So can you see that pasted? Okay.
Yes, sir.
Yes, sir. Then as per that, click on stats, click on basic statistics, and now see the essence of the Minitab. We can do everything here. One sample Z, one sample T, two temp paired. There are so many things, correlation, various, everything what we study today or yesterday that can be calculated this. But we must have that Minitab. It's not possible for everyone. So now it's a one sample. So I'm clicking on one sample. So what we got? We get that table. That what we seen in that PPT file. Then keep your cursor here. So automatically it will take C1 and C2 column data. Okay. So click the cursor on the main box. It is known as a selection box. Then select C2 column. Okay. Click on C2. Then click on select. It will be automatically transferred in that T50 box. Do you understand it? Okay. Then what is 126? That is our assume mean. So write that 126. In performed hypothesis test, what is your hypothesis mean? What you expect? We expect 126. And then click OK. Click OK. It takes time. Yes. Yeah. So that table I pasted in that PPT file. That I pasted here. So you can see that. So that is here. Okay. So again, it's very easy, but it requires practice. And see the answer. We are getting 2.44 in Excel sheet by our own calculations and by Minitab. But T-tab and acceptance rejections that we have to interpret. That software will not give. That simple software will not give. It can be given by SPSS and other things, but that are very costly, more than 5 lakhs. One version in one use. In multiple use for industry, it is more than sometimes 25 lakhs for use. So you can take screenshot of this. Why? Because this is important for Minitab. Those we can download the trial version and we can make our trials of our examples. So this is very one simple t-test examples. We can use Minitab, we can use SPSS also, we can use any software almost where t-test, Z-test and ANOVA are calculated. Then let's move with the unpaired test. What is that? I'm not going into the detail. What is XY for two groups? S1 square by N1 plus S2 square by N2 and so on. So these are the formulas. Now let's take the example. Just a minute. Yes, let's take that nicotine example. Nicotine content in milligram or 2 sample of tobacco was found as follows. One sample is X and second sample is Y. So we have 2 samples. In first sample, we have taken 5 times. In second sample, we have taken 6 times. So that Dr. DSP asked whether if there are different number of samples, can we use? And to understand that examples, to understand that things, we may have these examples. So here N1 is 25, N2 is 36. We calculated the things and we got the answer SCXY 2.293. Dx square, dy square, and put up that value in SCXY, and from SCXY, we calculated it. Okay. Then in TCal, write the mean of first, that is 24.6, mean of second, that is 29, divided by XY, so it comes to 1.918. In T-tabs comes to 2.26. So T-tab is greater than TCal, means it is there is no significance difference. HA is accepted and 2 samples are identical. 2 samples are from the 2 normal populations. There is no difference in between that. So we taken nicotine 2 samples. We analyze first sample 5 times, take mean of that and calculated it. Then analyze second Y sample 6 times and then have mean and calculation of that, and then TCal. Okay, so from that TCal is less than T-tab. So there is no significance difference in the data. Both are identical or both are similar. Same example I calculated using Excel and I got this. Let's see this. So open your Excel file, paste your data. So this is a screenshot of that. So paste the data. I pasted that data of X and Y. Then click on data. Click on data. Click on data analysis. When we click on data analysis, we'll get this menu box. From that, select 2 sample assuming equal variance. So click on this. If we click on that, we'll get this second menu box where we have to select X here, Y as a second. We have to click on the label, so we can have a X and Y. We have label of XY in our output. So click label. We selected including everything. We selected everything. Okay, with X. Similarly, we selected with Y. And Y is a label, so that is here also. We have to select. If you don't select, only if you select the data, then you will not get what is X and what is Y. So keep it and here select, click on label. Then keep your cursor where you want to have your output. So I kept output here, S10, and then click OK. We'll get the answer. We'll get this answer. So mean is 24.6 of X and Y, and T-test is 1.91. It is minus, actually Y data are greater, so here absolute value is not taken by the software, so we have to take it as a positive value. Here we are getting that T-tab, no need of that table. So we have this T stats means T calculations, and T tab means T critical. This is same value as T tab. This is same value as T calculation, but absolute value. And from that, we can conclude that there is no significance difference. So we can use Excel, but here we assume that the variance is equal. In example, they haven't said regarding that part, so we can take it as a equal. Otherwise, we may have to select the other things. Okay, so again, I'm repeating. We have two sample of nicotine. In first sample, we taken analysis 5 times. In second sample, we measured tobacco content, nicotine content 6 times. And then we calculated T by simple our calculation method. Then we go with Excel and we perform the T test, two sample assuming equal variance test. Data of the results are in same range of decimal points. Okay, so that is that things, and this is the table. This is unpaired second example. Again, we can do a same method. So I'm not going into detail of that. Why? Because we have to study NO also. Now, this is a paired t-test example. This is an important one. And generally, we are getting such data in fourth year or MPharm part. A new formulation A of marketed drug is compared for a market formulation B. So A is our formulation development batch and B is a market. Each received both formulations. We are comparing bioavailability and we taken 6 subjects, 6 subject participant received both samples in random order on 2 different occasions. On 2 different occasions. N number of samples. First time they given A formulations, measured the data. Then after wasite time or suitable time, same subjects were given B formulation market product and analysis was carried out and results are plotted or written in the table. The results AUC in terms of bioavailability are presented in the table. Check whether the new formulation differ in bioavailability from the marketed product or not. The alpha level is 0.05 or 5%. So calculation is easy. Even we can use Excel also. So first calculate the difference of both, then take mean of that. So difference of A and B, difference of A and B. So 136 minus 166, that comes to 30 minus 30. So here we have taken absolute value. Okay. Then this again absolute value and difference. And difference. Here it comes, this is a Excel essence. Then take mean of that and find standard deviation and mean. Okay. So from that, so I taken it ratio also. Here we can take ratio also, A by B also. Now this is a paired t-test. Why? Because same subjects are used. So we'll be using paired t-test formula, and formula is same, x minus mu bar upon standard deviation upon root of n. By calculation formula is same, and we are getting t value to 3.47 and t tab comes 2.57. So t cal is greater than that. So there is a significant difference in bioavailability of both. Similarly, we can go in Excel and we can perform the paired two sample for means. Here both are different. It is a paired. They are dependent. So again, by same way, click on data. First, open an Excel file, paste your data, click on data, click on data analysis, and click on pair two sample for means. Then menu will appear, menu box. In box, select the variable A, variable B, click on label, keep cursor where we need that output range, and click OK, we'll get the answer. Again, same answer we are getting here. You see, same things, T critical and T tape 3.48 and so on. Okay, so it's very easy to have that things. So till now we study the Z test, T test, one sample and two sample, independent, paired, and dependent. Okay, so four types of things. Now we are going with the ANOVA. Now here we have two groups for same subjects given dose two times. So one group X bar, S1, N1, second group Y bar, S2, N2, and from that we calculated T. But suppose we have three groups, then how T can be calculated? Suppose we have three groups. We want to compare these three groups. Then how we can do? We can do by using ANOVA. So we thank to the God for providing the ANOVA calculation in the brain of the scientist. And that brain is Ronald Fisher. It was very dynamic and intelligent person. And what he invented that is used since 1890 onwards. So more than 140 years, 30 years. Now, T test compares the observed difference in the mean, while ANOVA, analysis of variance, compares the observed variance among the means. So what is the variance in the mean? That is concerned with the ANOVA. While T test, what is a difference in the mean? Difference in the mean, that is T test. I'm not going into the theoretical part detail, which is required that I will do. Now, degree of freedom is the essential part for ANOVA. And degree of freedom is always taken as n minus 1. And how it is related, that we'll see somewhere. Yes. Again, this is also a theoretical part. I'm not going into detail of that. Yes, this is important. In one way, means single factor ANOVA, it is a technique that partitions the total sum of the square of deviation. Now it is related with variance. Variance is xi minus a whole square. And from that, root of that and other things we are going to calculate. So sum of the square of deviation, sum of the square of the deviation of the observations about their mean into portions associated with independent variable in the experiment. And we assume something that the data are randomly samples and independently chosen from the population. We were not biased, it is unbiased. Data are normal distribution data. The variance.
Sir, your voice is not clear, sir. It is breaking in the middle. Hello, sir. No, sir, your voice is breaking. We can't hear you. Sir, unmute. Sir, you can unmute now and
please go. Okay, thank you. Okay, is it okay, sir?
yes, sir.
Yeah. Sorry, there is a raining part here, so there is a disturbance in that things network, sir.
It's okay, sir. No problem, sir.
Okay, so I'm going with the main component. Please, participant, be well this. This is one of the important slide in ANOVA, one-way ANOVA. We know that ANOVA measures the variation. Now there are two types of variations. One variation is variation due to the treatment. If we give product A or sample A or whatever that's, so there will be variation to untreated and treated. So that variations comes under BSS, between group sum of the square. In software and in books, they write as BSS. TSS is total variation. TSS is the total variation. Okay, so this is a TSS. TSS is of two parts. One is BSS, that is between the groups. So what is the difference between treated and untreated? That comes in BBS. And there may be a difference due to inherent difference due to variation. And that difference is known as within group sum of the square, WSS. Within group sum of the square. So that is the things here, sorry, WSS. So there are, again, I'm speaking two types of difference between the group A and B. And again, second, in group B, number 1 and number 2, patient 1 and patient 6. Similarly, in group B, second group, patient 2 and patient 1, and so on. So that variation is an inherent variation, that is WSS, and BSS, that is due to the treatment variation. So why when we are treating something, it gives effects, that effects comes in BSS. Okay, and TSS is always sum of BSS plus WSS. So B means between and W means within. So let's understand. Again, this is also an important slide. I try to present it in a graphical way, in a figurative way, so with anyone can understand. Now we have data. This is our first group. This is our second group. And this is our nth group. 2, 3, 4, 5, and so on. One last group. And let's number the persons. First group is Y11. Second person Y12. 1 is group and 2 is number. 1, 3. So this is a first group data. Similarly, Y1 N or whatever that's. Similarly, for second group, Y21, Y22, Y23, Y24, and Y2N2. Similarly, I group, I1, I2, and IJ. J is the number of last person. So this represents the data part. Now what we have to do here? We want to calculate the total variation. Now in terms of what? So first total variation is y11 means this minus y bar. Y bar is the mean of the total. So sum of all and divided by the total number and get mean. So overall mean, mean of the total observations, that is y bar. So first observation minus y bar. Similarly, second observation and so on. Here I haven't written all observations, but plus y12 minus y bar square, y1 n1 minus y bar square, and so on. So this is first. Similarly, this is a second. Similarly, this is a last. In total, that sum is in statistic, it's written as y1ij minus y bar whole square. If we calculate using the data as such, it will be very difficult and time consuming. So if we simplify a minus b whole square is a square minus 2ab plus b square and so on things, it gives, after simplification, it gives a red color formula. That is a very simple formula, that TSS is equal to sigma Yij square, means square of first plus square of second plus square of third and square of last, minus sum of all its square divided by n. If we simplify that large formula, this will be the shorter way. In here, the last bracket is known as CT, correction term. And it is most important, it will come everywhere, correction term. So TSS is equal to square of first observation plus square of second plus square of third and square of last minus sum of all whole square divided by n. So this is TSS and total sum of the square. So manually, if we do it, it is very difficult. I did it 1 or 2 examples. You will see it and then we'll see by software also. So that is TSS. Then second is between the group. Between the group. So what is the difference between first group, in between, second group and third group? So we have taken overall mean, that is y bar, overall mean, that is y bar, sum of all divided by number, then mean of first group, that is y1 bar, calculate mean of second, that is y2 bar, and mean of last, that is yi bar. Okay, so this is calculation for BSS in between the groups. So BSS is equal to N1, so number of observation in first group, into observation 1 minus observation 1, sorry, observation not 1, mean of first group minus total mean whole square. So y1 bar, it is not y1 only, y1 bar minus y bar. So y1 bar minus y bar whole square into n1. Similarly, n2 into y2 bar minus y bar whole square. And last group number ni into its observation minus mean. Okay, its mean minus total mean whole square. And again on simplification by a minus b whole square, we get that red color formula, sigma ti square by ni minus This is city. Now, what is Ti square by Ni? And what is its sigma? This is sigma. So here T1 square by N1. Now, what is T1 square by N1? Now, here I have taken three results. And T1 square means sum of total of all observations whole square. T means total of first group observation whole square divided by the number of observations. So this is T1 square by 3. Similarly, here I have taken 4. So similarly, y12 sum of the second group whole square divided by number. If it is 4, then 4, or if it is n2, then by n2. Similarly, third group and so on. So sum of all that T1 square by N1 plus T1 square by N2, T2 square by N2 plus 3T square by N3 plus Ti square by J, that comes here, minus again Ct square, and that is between the group variation. So again, that is difficult to calculate. We'll see it. Just you understand it, no need to mug up these things. Keep in mind that what is WSS, what is BSS, and what is TSS, and how they are derived. You don't know the method, you have to remember the method, but in mind, you have to remember that it can be done by this way. Similarly, WSS. So first observation minus its mean whole square, and their sum of first group, similarly sum of the second group, sum of the third group, and we'll get WSS. In all, I written that three formula, and TSS is equal to BSS plus WSS. So total variation of sum of the square is equal to between the group plus within the group. Okay, so this is important concepts to understand. Now let's take one example. We'll solve the examples by Excel or suitable software. Now, 15 tablets are taken for the comparison of the three different assay method ABC. We have two methods, titration, UV, and HPLC. And that 15 tablets were comparison for the amount of drug or content or assay. The results of assay using three methods presented in the table. For method A, first 5 observations results. For method B, first that between 5 tablets analysis, and last 5 tablets were analyzed by HPLC or method C, and the content of drug or assay content is presented in the table. So it looks easy. So first sum of all, find mean of it and standard deviation of each group and total. Each group and total. So I did it at the bottom also. I calculated that things. So this is for first group total. This is for second group. This is for third group. And if we see the data, all mean are different. Here it is 99, here it is 102. So there is a difference, but that's not out of the limit. So this is observations. Calculations, what we get, let's see. So have the methods, data, mean and standard deviation. Then hypothesize it and calculate TSS. So TSS is sum of the square of all minus CT. Sum of the square of all. So you have first observations, its square, second observations, in the 15th observations. 5 of first group, 5 of B method, and 5 of C methods divided by, sorry, here up to here, sorry, I'm sorry, up to that all groups. This is first group, this is second group, and this is third group. So square of observations and sum minus CT. CT is this, and it comes to 38.933. Similarly, BSS comes by formula 13.73. I use Excel file to calculate that things, and I did here all that things and pasted here. Okay, so TSS, BSS, and difference of that will be 25.2, and that also verified as WSS. So this is the calculation part. So this is WSS. Then calculate the degree of freedom, total degree of freedom, total 15 observations. So n minus 1 is 14. Between the groups, there are 3 groups. So 3 minus 1, it comes to 2. Within the groups, so first group we have 5 observations. So 5 minus 1, second 5 minus 1, third 5 minus 1, or 15 minus 3. So degree of freedom 14, 2, and 12. 14 is total, 2 is BSS for BSS, and 12 is for WSS within the group. Then put up in this table. This is always this table is required when we calculate ANOVA. This table is required, whole table. Then we calculated that DF 2, 12, and total 14. Then sum of the square, BSS we got, TSS we got, WSS we got. So this is our calculation part. The third column or second column of the results. Then mean of the square. So BSS divided by BDF. BSS divided by BDF. 13.73 divided by 2 is come to 6.86. Similarly, 15.2 divided by 12, it comes to 2.1. And F is equal to MS divided by MS in between divided by MS within. So this is the formula actually. This is the formula. So 6.86 divided by 2.1, and it comes to 3.269. So F value comes to 2.26 in ANOVA. Again, go with the table and calculate F tab. It comes to 3.89. It comes to 3.89. 3.89 is greater than 3.26. So T tab is greater than F cap. Hence, there is no significance difference. What we assume that is accepted. So result doesn't differ significantly by the method. Results from the method A, method B, and method C, that doesn't differ significantly. So here we can compare method A, B, and C by analyzing the tablets. Okay, so which method is better, or what is the difference that can be done using ANOVA? Now let's see how to go with Excel file. So click on data, prepare a table first. So I pasted that table here. This table I pasted there. Okay, so click on the paste the data. So I pasted the data. Method A, method B, and C. Open Excel file, paste the data, click on data. Okay, and then second step, click on data analysis. Then keep your cursor here to get your output. And then click on data analysis. What will achieve? We'll achieve this menu box where select single factor ANOVA. Here, one factor, that is amount of drug, that is assay. No? Level are three, method 1, method B, method 3. Three level, but factor is 1. So it's a single factor method. Click on single factor. We'll get the box. Select the data table as an input range. So this is an input range. So this is total data. We have to select the total. Keep your cursor in here. Then click on label, the first row. Now here we have column and table. So do you want to use row or do you want to use column? So we are going to use, okay, labels in first row where we have to label. Then group by columns here. And then paste where you want to get your output. Okay, then we'll get this output. I think, yes. So that output we have. So this is a bigger part. So F, what we got there, MS and SS and DF and everything, almost they are same in digitals. So F tab is 3.88 and F calculation is 3.26. So there is no significance difference and HO is accepted. Methods doesn't differ in analysis. So we can use Excel file in that way. So this is summary of this. Today I'm not keeping the recess. Hello? Hello, sir.
Yes, sir.
I'm not keeping time gap. No, I'm continuing and finishing the things.
Yes, sir.
Will it is advisable or can we keep some 5 minutes gap?
It's good if we can give some 5 minutes.
Okay, so after completion of this slide, why?
Okay,
Because
sir.
it is
11:45.
started at 10:30.
Yes, sir.
So it is 11. So 1 and okay. So within 5 minutes. Okay, I'm completing that things. I'm completing some introductory part of 2A. Then okay.
Yes, sir.
So summary of one-way ANOVA. Important things is TSS, BSS, and WSS. Which design we want, have the data, choose the level, choose the factor, and perform the experiment and have the data. Then get BSS, WSS, and so on. And paste the data in the table in Excel file, Excel sheet, and go as per the step we did it. From that, we can get F calculate and F tab. F calculation, that is F statistics, and F tab, that is F critical also. And from the value of that, whether it is less than, greater than that things, conclude yourselves. Whether HO is accepted or not, or rejected, or whatever. Is the difference significance or non-significance? In our example, it was not. Okay, so that was one way. Now, two-factor ANOVA. This is an important thing, and similarly for three-factor also we can do it. Two-way ANOVA compares the mean of population that are classified in two ways or two mean differences of the two factors. There are two or more factors or independent variable. Factors are here independent. There may be equality or inequality. So ANOVA tests the equality of the two or more populations mean with several independent variable which are used. And if we use t-test for two factor ANOVA, and for that result will be same. The output will be same, one slight method is different. Now, one-way ANOVA is the extension of the two independent group t-test. Two independent group t-test means unpaired. Okay. Two-way ANOVA is the extension of the dependent groups, that is paired t-test for more than two treatments, more than two vectors. Okay, like method A, B, C, and so on. There we did the analysis. We may have second parameter also. The two-way design is also known as randomized block design. This word is widely used in examination. Generally, examiner asks this. Why? Because students are not familiar with that word. So I intentionally written this sentence here in the notes. In design, in randomized block design, why it is a block design? The unit is labeled as a block. In randomized design, the treatments are assigned at random to each experimental unit. Each unit, and that is one block, second block, and third block. So it's a randomized block design. In clinical trials, I'm not going into that part, it's not required. Now, assumptions. Two-factor ANOVA, depending on the assumptions, if they are not satisfied, then it will not give exact output. It may give output, but output cannot be conclusive. So first, it should be normally distributed. There should be homogeneity of variance, means equal variance, and independent random samples. There should not be bias in selecting the sample. Two-factor 3 level, that is known as the 2x3 ANOVA. Three-factor 4 level, that is known as the 3x4 ANOVA, and so on. Okay, so that is a two-way ANOVA. We understand this, and then we'll, before example, we will conclude the things of first part. Like previously, we written that TSS is equal to BSS plus WSS, but here it is somewhat different. Why? Because factors are two, at least two. So TSS is equal to SSA plus SSB plus SSAB plus ESS. Now, what is SSA? SSA is a difference in group A or treatment A. SSB in treatment B, variation due to treatment B. SSAB means what is the interaction between A and B? How A interact with B or B interact with A. And ESS, that is a inherent error, that is random sampling error. Okay, so here SSB plus SSA, other things is almost same. Assumption is same. Advantage is it is more efficient. ANOVA is more efficient to study two-factor simultaneously rather than this separately. One can reduce the residual variation in a model, and one can investigate interaction, how A method, A treatment interacts with B. Is there anything? And this is a table where we have to write the data. What is TSS? What is the formula that I written? There I narrated in detail. Here I written just in a one slide. TSS is equal to sigma of observation square minus CT. Same to that. Sum of the observation square. Okay, minus CT. Now here we have column and row. Why? Because there are two factors. So SSB, that is column, SSA, that is row. Row is generally taken first in software, so it is I written that in black words. Black is by software, and CSS and RSS, that is used in books and literatures. So these are the formula. And if we have any 4 value, we can calculate the fifth. If we have 4 value of that, we can calculate fifth. If ESS is not with us and we have TSS, SSA, SSB, SSAB, then we can calculate ESS. No need to go with that laborious calculations. Now, this is again important concept. 2-way ANOVA without replication. Generally, this model is more taken. Why? In experiment, each cell contains a single reading. In our data, we write a single reading. Suppose we measure systolic pressure of the participant, so it will be 122. So it's a single reading. We cannot write 122 and comma 123 in a single cell, no. So it is not replicated. There is no replication in combinations of that factors. The well-known method of paired comparison is special case of 2-way ANOVA without replications. Without replications. With replications, there are so many examples, but I think in introduction part, I omitted the slides also. I written what is that, but it is not required just now. Why? Because generally without replication is more used in our studies. So this is an example without the things replication. So we'll see this example. Okay. So we have breaks for 10 minutes. So we'll start exactly at 12:02. Yes, sir.
Yes, sir. We'll start at 12.
Yes, we will start at 12. Okay.
Okay, okay,
So
sir.
thank you, sir. I'm not leaving okay.
Yes, sir. You can leave the screen like that and join back after 10 minutes.
Takes time. My network today something there is some mistakes there. Okay, okay, sir.
Okay. Okay.
Yes. Hello.
Yes, sir.
We can start, sir.
Yes, sir.
Dear participants, okay, sir, I'm starting.
Yes, sir.
So, yes, two-way ANOVA. So, how and what is TSS, what is SSA, what is SSB, what is SSAB, and what is ESS? We studied, we understand it, we have given the formula. No need to mug up that formula, just you must, your mind should be ready to use that formula. So what's the difference and why? Yes. Now let's have an example for two-factor ANOVA. There are 8 labs are requested to participate in experiment to compare the dissolution rate after 30 minutes of 2 generic products A and B and 1 standard product C. So we have 3 products A and B. They are 2 generic product, A of A company, B of B company, and standard C is a marketed product, well-known marketed product. And the data gives the dissolution rate after 30 minutes. So amount of drug release after 30 minutes. The objective of the experiment was to determine whether the product A, B, and C or C had different rate of dissolution. So are they similar in dissolution or not? Is there any difference, significance difference in between that? B, to estimate the lab variability, lab 1, lab 2, lab 3, and lab 8. Is there any variation between that for the products? And or test of significance difference among the laboratories and among the products. So have that things in the mind. So here A, B, and C, okay, sum of A, sum of B, sum of C, mean of A, mean of B, and mean of C, and sum of all square. Sum of all square. Now here we have 3 products. So in significance test, what we can hypothesize? Let's hypothesize that mu of A, mu of B, and mu of C are equal. There are so many things possible here. Mu of A may not be equal to mu of B, which may be equal to mu of C also, and so on. So I'm not going into detail of that. Just see whether their dissolution rate after 30 minutes is similar or not. That we'll see in between and in all. So calculated mean of A, B, C, and standard deviation in some of the squares. Then we calculated TSS. We calculated CSS, means column A, B, C. Okay. We calculated row sum squares, means product lab A, lab B, and lab C, and so on. Then interaction between this by given data. So ESS is equal to TSS minus CSS minus RSS. We calculated TSS by the formula and it comes to 997.8. We calculated CSS. Okay, we calculated CSS and that comes to 200.3. We calculated RSS row sum, that comes to 391.8. And using all the 3 values, we calculated ESS, that comes to 400.7. Now degree of freedom, total we have 8 into 3, 24 minus 1, so 23. Column, we have 3 ABC product. So 3 minus 1, it comes to 2. Row, we have 8. 8 minus 1, it comes to 7. And residual C into R, C is 2 and R is 7. So 2 into 7, 14, or 3 minus 1 into 8 minus 1. So that we calculated, and from that we calculated SS, MS, and F. F between the products is 3.5. F between the laboratories comes to 1.95. F for the products from TAB, it comes to 3.74. So 3.5 is less than 3.74, means products are significantly different. Significantly different, 3.5 and 3.74. Okay, similarly, 2.76 from F tab for the row, it is, and for laboratories, it is 1.9. So 1.9 is less than this. So there is no significance difference between the labs. So TCal is less than TTAB. Here, TCal is less than this. So no significance difference between A and B, and similarly labs. Okay. Now I used Excel, and from that we obtained F 1.93 for rows or columns. How to do that? Let's, I think why? Because this is an important thing, and I summarize this in one slide. Go with Excel sheet, paste your data, click on data analysis, then click on ANOVA two-factor without replication. ANOVA without replications. Then in dialog inbox, select the input range, total with label, and click where you want to have results, and get the output. And F is 1.93 for rows, for columns, T critical, T for rows and column, and from that we conclude the things. Okay, so again, without replications, let's yes, just a minute. Excel file is open. Can you see the Excel file?
Yes, sir.
Excel file is open to all. Can you see it now?
Yes,
Sir?
sir. Yes.
Yes. So I pasted the data, open the Excel file, I pasted the data. So these are the data. Product A, product B, and standard market product C. Then go on data, click on data analysis, then click on ANOVA two-factor without replication. So it is third one, with replication and without replication, and click OK. We'll get a table where input range. So can you read it, the things? Is it readable? Size is okay?
Yes, sir.
Okay,
We can
then,
read, sir.
yes,
Input
yes.
range, output range.
Yeah. So I selected input range, that total with label and everything. Then click on select label. Then click on output range. Put your cursor where you want to have the things, and click OK. So process are easy, but interpretation is very difficult. So it will ask to reprint it again. So why? Because I'm using same things second time. So we are getting the output, and that is being pasted. So my advice to the participants is that you use Excel for Z, T, and NO. Have your own example, prepare a file, and if you have any problem, you can contact me. I will guide you by WhatsApp or email to solve your problems using Excel. If you have MATLAB, SPSS, you can see my screen. I have this mini tab. I have this is SPSS. This is Minitab 18. Okay, I have other softwares also. So if you don't want to have, you don't have that things and you want to have your output using this software, you provide me your data, I will give you the Excel file like this with your outputs. Okay, but my intention is that you must have clear concept to solve the things, and interpretation is a very important thing. You should interpret your data individually by yourselves, and then you should guide your teacher also, your guide also. Okay, so that is this part. And now, yes, this is a regression. Okay, we'll do that after what is regression and other things. So that ends the ANOVA part up to 2. Again, there is one important concept here, but it is not widely used. It is known as HSD. HSD. Turkey honestly significant difference test. That is known as a Turkey HSD test. It is, I know what, and it is a multiple comparisons. If we want to compare group 1 with group B, group 1 with group C, A with B, A with C, B with C, and so on. There are more than 5 groups, 3 groups, then how that can be done? So that can be done using this Turkey HSD test for ANOVA. It is very complex, so I'm not going into the detail of why, because theoretical part will need some basics of the two-way ANOVA. Basics. Just I introduced to you with two-way ANOVA. And this is the formula. Just we'll go aeroplane view or flight view. That formula is there. What is MSW, what is NA, what is QA, and that you have to read and interpret also. This is an example, but it takes so many things in comparisons. So I'm not going into that examples. Okay, this concept is more important, regression part. So regression and chi-square, we'll complete that within 45 minutes before 1 or 1:15. Now regression, to understand regression, we must understand correlationship. Now correlation indicates the relationship between the two variables. Suppose we have variable X and Y. So what is relationship between them? The relation doesn't necessarily indicate a causal relationship. Why and how that is? Regression determines the functional relationship. Suppose y is equal to 2x plus 3. How x and y are related? Y is equal to x square plus x cube minus xy plus this. So how x, y are related in that, and that is a functional relationship. So regression indicates the functional things. Okay, so that's the difference between that. Correlation is not required in depth, but it is known as a bivariate statistics. What is relationship between x and y? Now relationship may be positive or negative. There is, if one parameter increases, second also increases simultaneously. So that relationship is positive relationship. Suppose child height increases, definitely weight increases. So relationship between height and height and weight of a child is a positive relationship. Similarly, negative relationship as y increases x decreases or x increases y decreases, whatever sets. So relationship between sleep and mark. Power of sleep increases, definitely mark decreases. So it is a negative relationship or inverse relationship. Different mathematics. Both parameter.
Sir, did you start, sir?
Sorry. Hello.
Yes, sir.
I was unmuted, I think. Okay. Okay. I'm repeating the things. Don't worry.
Okay, sir.
So R will be value of small r. Correlationship is represented as small r, and it is between -1 to 1. Is it? I'm audible, sir.
Sir, audible, sir.
Okay, and slide is okay.
Yes, sir, visible.
It is a correlationship R.
Yes, sir, correlation
Okay,
coefficient
so
R.
network is slightly weak, I think, due to that weather condition is bad here.
Okay, sir.
Okay. So positive relationship as X increases, Y increases. So it's a positive. As X decreases, Y increases. It's a negative relationship. Uh, as height of child increases, weight also increases. So it's a positive relationship. As hours of sleep increases, number of mark of a student decreases. So it's a negative relationship. Then correlation may be simple and multiple or complex. Again, simple is only two variable, X varies with Y or whatever stats. In multiple, there may be two or three or more variable, and Y may be partially related on X and Z, or totally related with that. So it's a partial relationship and total relationship. So we are not going into detail of that. Similarly, linear and non-linear. Suppose in calibration curve, when we create a regression, we are getting a straight line. So it's a really linear relationship between concentration and absorptions or that things. So these are the methods to find correlation graphically and by calculating. So we are not going into detail of this. These are the general methods. But correlations is required to understand coefficient of regression. So just we have to give the ideas. So this is not required. I'm not going into detail of that. Why? Because that takes more than this. Now our intention is regression analysis. Now correlation analysis shows whether there is a relationship between the two variable, two data sets, two groups, or two patients, two blocks, two units, two methods, or two products. Regression goes a step further and asks how they are related. It shows relationship in number of quantifications. Regression analysis derives a mathematical equation like that in standard curve, y is equal to something plus something and r square is this much. There we write small r square. So it's a relationship and here it is a regression. It derives a mathematical equation which allow us to predict one variable at different value of the other. From equation, if we put value of x, different value of x, we will get the value of y. And we get a line of best fit in the regression analysis, and which is based on the LSD principle, least square difference, like that we see in SS, that is sum of the square. Here it is a least square difference, minimum difference between xi minus y or x and y, minimum difference. So line of fit principle based on the LSD. And generally all softwares, their functions at the end goes with LSD principles. This is a very, if you see the equation, Rxy is equal to this. It looks very complex. And if we calculate it, it takes more than an hour. But if we use Excel, it takes only 2 minutes. So I'm not going into detail. Yes. Now R square, what is R square? It is the square root of the small r. Correlations are, that is small r. So square root of small r, that is R square. Regression analysis value. And adjusted R square. When y adjusted R square is required, it is an important concept. It represents the percent of variance. Percent of variance. There is variation. And what is the percent amount of variation? Variance account for the dependent variable. Suppose y is dependent on x. So percent of variation of x on y or y on x, that is represented by R square, adjusted R square. And it is always lower, slightly lower than the R square value. Adjusted R square is slightly lower. Why? Because it is a percent variation accounted for the dependent variable. The larger number of independent variable, the lower the adjusted R square. This is usual things. And why R square is there? Why it is required? There is some deviation, we say the fluctuations in the in the readings or variations, sorry, not variation, deviation in the readings. So that fluctuations in terms accounted as an inflation, So how much deviation, percent variation will be there? That is accounted by adjusted R square. So adjusted R square is the adjustment made or the expected inflation in the sample. How much inflation will be there? That fluctuation that can be decided by the adjusted R square. Multiple regression analysis, that is an important one, and from regression we get the things, we predict the our y from different x. So prediction is the one of the most important. I'm not going into detail why this is not required. This is also not required. And this is we seen just now. There are things how it is done. Yes, that we did. Yes. Now in regression analysis, we get slope and intercepts. Generally, intercept is written as alpha and slope is written as beta. What is slope? The formula are given, no need to remember it. So it is a sum of observation minus mean of x into sum of here there is mistake, sigma y, it should be total in that bracket. So sigma of y observation minus mean of y whole divided by sigma of x minus x bar square. X minus x bar square and its sigma. In first, you have to show it by pointer. So this is observation minus mean of x. Each observation of x minus its mean and its sum of that difference. Similarly, here there is an error. This should be here. So sum of yi minus y bar, sum of xi minus x bar square. So first square it and then sum it. So that comes to b. B is a slope. B is a slope. And intercepts that comes by formula sigma of y minus b into sigma of x divided by n. And in all it is written by this also. It is written by that. So this calculation is not required in Excel. But if you want to do by calculation, it's very complex things. I tried it for one example. Weight in systolic blood pressure data of 10 male patients are given. Find the regression analysis. What is the relation between pressure and weight? So data are given here. Let's just take highlights of that. So these are the data. Okay, and I converted that in terms of this. So have sum of all, let it is x, pressure is y, sum of y or whatever, so we can write. This is x, this is y, mean of x and mean of y, divide by that 10. Then each observation minus mean. So 165 minus 190.7, its square, that comes to 660. Similarly, second and so on, and sum of that. Similarly, for yi minus y bar and sum of that. Then xi minus x bar into yi minus y bar multiplications. So that column will be required. We have taken square here directly. Okay. So from that, obtain the values in equations comes calculate alpha, calculate beta, and I calculated here at the bottom. Beta comes to this much, that is 0.2903, and alpha comes to, I think, alpha that we calculated using, that is 80.74 by the formula y bar minus b into x bar. So from that, we are getting alpha beta and we are getting the equation y is equal to plus y is equal to 80.74 plus 0.2903x. If we use Excel file, again we can get it, and this is a Excel file. I haven't gone into the regression Excel file for that data. We can go for, yes, I think this is for this one, between X and Y. Okay. So we can get more information that detail. So Y is equal to, for this is 0.048, small r is this much, and everything Yes. Now,
Sir, you are visible, sir. Audible also.
okay, audible. Last 10-15 minutes, chi-square test. Simple formula. My internet is unstable, very weak. Okay. So chi-square is equal to observation mean minus expected whole square divided by expected. So it is very simple formula. Where and how it can be used, that we have to see, and then we can calculate one example. Sample must be random. Method of selecting sample must be random. Data may be qualitative data and discrete, not continuous. Overall total is 640 or more, or depends on. So in example, we are taking some parts only. So these are the things, and how to do that, let's see. So observed means what we actually get from the results. So actual account value in each category. Expected means predicted, what we need. So that things. Very simple test. It is a random. Let's just, this is a, yeah. I think this will be very complex things. Can we have a simple sum? Okay, let's take first only. An American Pet Product Association conducted a survey in 2011 and determined that 60% of dog owners have only one dog. One dog, how many people? 60%. Two dog, 28% people. And three and more, 12% people. So they take a survey, and from that they found that one dog owners around 60%, two dog 28%, three and more 12%. Determine whether the data support the results of the AAPS study, and significance level is 0.05. Okay, here what they have given, out of the data what they provided that total they surveyed 129. Out of that 73, one dog, 38 has two dog, and remaining three or more. So these are the data, and the percentage they given it. So let's assume mu1 is equal to mu2 and so on. Significance level 0.5, so 5%. And here we have three groups, one dog, two dog, and three and more. So 3 minus 1. So degree of freedom is 2, DF is 2. Okay, probability is 95%, 100 minus 5. 73, 38, total out of 129. So 18 will be 3 plus. Now, what is expected? They expected that 60% one dog. So 60 into total 129 divided by 100, that comes to 77.4. So expected is 77.4. Similarly, for two dog, expected is 36.1. For three and more, expected is 15.5. Okay, and that total sum is 129. That total sum is 29. If percentage sum we take, it will be 100. But from percentage we calculated for 129. Now, chi square is equal to sum of all. So 70 3 minus 77.4 whole square divided by 77.4. So this is work of fifth standard students, a school student. Similarly, second, 38 minus 36.1 whole square divided by 36.1. 18 minus this divided by that, and so on. And it comes to 0.7533. Now, chi-square from that table, it comes to 5.91. So here 5.91 is so many times greater than the chi-square calculation. So chi-square calculate is less than chi-square tab. So HO is accepted. Means 95% time out of the 100. Now here, see these things. Agree with this sample, have x square value 5.991 or less. Then we have to accept it, that is accepted. So survey supports the data of AAP. So from value of x square, chi-square tab and chi-square cal, we can calculate the things. Other things I'm not going into detail. Similarly, second example, this is a placebo part. Again, calculation are same. And at the end, let's take one. Yes, this will be more easier to understand to these students. Example third, six-sided die is unbiased. Outcome is equally liked. So one can be, probability of 1 is 1 by 6, probability of 2 is also 1 by 6. The die is rolled over 240 times in an experiment, and the outputs 1, 2, 3, 4, how many times they are plotted in the table. So frequency of 1, 2, 3, and they return. At a significance level of 0.05%, is there any evidence to support that hypothesis that die is unbiased, whether it is biased or unbiased, out of 240? Out of 240, the data are given. So phase 1, 34 times, phase 2, 44 times, and total 240. Now expected output, that is 240 by 6. How? Total is 240 and there are 6 sides. So each side has a chance to come 40, 40, 1, 2, 3, 4, 6, everyone. One side may be 40 times, second may be 40 times, if it is unbiased. Now observations are 34, 44, this. So find the difference of observations, square it and divided by E, and that comes to 0.9, 0.4, 2.5. So formula is actual minus expected square divided by expected. And that total comes to 8.35. Okay. Now chi-square from the table is 11.1 and chi-square by calculations comes to 8.35 by 8.35. So we calculated that by table, so it is 8.35 by calculation, sorry, and by table it is 11.1. So 11.1 is greater than 8.31. So chi-square table is greater than chi-square calculation, means there is no significance difference in the data. So it is accepted. The die is fair. Actually, it should come 40 times each, 40 times each, but it depends on the number of observations. So that variation is 6, that is in the limit of that 0.05% that they say. Okay. Now this is a detailed chi-square test. We are not going into that detail. MS is widely used. Why? Because sample size is greater than 30 and variable are ordinal. Fishers is also used. Pearson chi-square is uncorrected one, and uh, Yates is also used in examples. So we are not going into detail of everything things. I think this we are not going into rank part, KW part. Okay, so we are not going into detail. That's at the end. I'm very much thankful to the participants to stay with me for these 2 days, total more than 6 hours or 7 hours around. I'm responsible what I said, but I'm not responsible what you understand. If you understand and if you write in a correct way, then and then I may be. My intention is not to criticize anyone in the presentation slide, whether die 1 is good or die 2 in a side 2 is good. That data are assumed data, and I'm not, my intention is not to criticize anyone in that. Disclaimer, the opinion and the results expressed in the presentation are solely my, it is my personal, they are not related with my organization or my association or with my friends or with the chips also or with my parul pai. The images, some images, some tables, some figures used from the public domain, the data or examples taken from the examination of the universities or some books. But all these are for educational purpose. I'm very much thankful to that public domains from where I took that images, examples, and figures. I'm very much thankful to them, and I need that, I welcome that contribution in the educational development also to make the concepts of the students clear and to for easy understanding. I'm very much thankful to my guru, guide, and more than God. He is my PhD guide, my PG guide, my mentor from 97 till his death. I'm very much thankful to Goel sir. Why? Because what I studied, that is his contributions. Thank you all. I invite questions from the participants, but before ending the last slide, I will stop sharing and we may have interaction if it is required. Many thanks to the all member of teams, to the principals, to the coordinators, to the all staff members, to the anchors, to the faculty members. Thank you all. Stay safe and secure. My best wishes to all of you for your innovative achievements further in pharmaceutical field or where you are. My principle is learn, digest, and perform. My principle is learn, digest, and perform. That is LDP. Thank you all once again. Thank you, sirs. I invite questions from the participants, and I'm stopping the yes, sir.
Okay, sir.
So just a minute. I'm
Sure.
summarizing the thing, and before that, you do that things within 2 minutes. So we started with the statistic, descriptive, interference, then data, then normal distributions, uh, parametric, non-parametric, some tables, then uh, Z test, T test, ANOVA, and chi-square. So these are important for research methodology syllabus PG syllabus, UG syllabus. So I taken that things. If you have any problem, participants, you can contact my mail. I can give my mobile number, but it may be misused. So if you have any problem, contact me my mail. If I feel that some direct interaction is required, then I may provide your number to you by email, my number, through your number. Thank you all once again. Thank you, sir. Okay, sir. Thank you, sir. Good afternoon, sir. Sorry to disturb you at the end.
It is with pleasure, sir.
I tried my best to summarize and to give some
Yesterday
idea.
I could not respond to your WhatsApp message.
Yes, sir.
Yesterday, myself, Narayana sir, and we are all with the University of Arizona. We have a meeting with them.
Okay, sir. Okay.
So I could not respond to your WhatsApp message.
Okay, sir. Okay. Thank you. Thank you, sir. No, you are very busy. You are
It is
very
our
busy.
great pleasure that you have spent your valuable time with us and gave us very good information on biostatistics, sir. It is really great and much useful for the youngsters as well as researchers, sir.
And that was
thank you very
that
much,
was
sir.
my intention, sir. And
Yes,
so
sir,
I
yes,
asked,
sir.
so I given you that clue that biostats will be more useful to the our staff members,
it is
to the
really,
PG students also, and to the
yes, sir,
PhD
it is really
students.
an apt to this thing, sir.
I given the introductory part. Just I imbibe their seeds.
Yes, sir, yes, sir.
It
100%, sir.
depends on their efforts.
Yes, sir, yes, sir.
We will be useful to them. We may be support them. We may guide them when
Yes,
and when
sir.
required, sir.
Yes, sir. Yes, sir. 100%, sir. We utilize your expertise, sir. We need
Thank you,
your
sir.
blessings
I'm
all the
with
time
you.
for our
I'm
college.
with you, sir. I'm with you, sir. I'm ready to give this presentation every year to the new students, new PG students.
Sure, sir.
It will be my pleasure.
Every year, definitely we will
Definitely, sir.
make it possible, sir. Just
Yes.
because of pandemic, we could not able to make it quite frequently. But however, at a
Yes.
right time and at a right decision has been taken by you, and it is
Yes, sir.
really worthful to the students who are going to write the examinations also, sir.
Yes, sir. Yes.
Sir.
Yes. Any problem by any students, if there is, Dr. P. Vijetha written that thank you. No, thank you is okay. No, it's my duty. Dr. P. My
She is
duty. It's my
pharmacology
duty.
HOD.
My
She is
duty. It's my
pharmacology
duty.
HOD at our college, sir.
Oh yes, sir. So, sir, it is my duty, but I expect some questions or some
Sure,
doubts.
sir. Sure.
Some doubts.
I
You can
think,
send by
Dr.
email. You can send by email, sir. Thank you,
Yes,
sir.
sir.
Thank you.
100%.
Thank you your feedback.
Raghav Kalyan,
Sir. Sir.
Yes.
I think we can propose vote of thanks and we can
Yes, sir.
conclude the program.
Yes, sir.
Yes.
Dr. Ramesh. Dr. Ramesh. Okay, please carry on. Kalyan.
Yes, Ramesh sir joined.
Ramesh, is there any concluding remarks?
Hello.
Yes, sir. I will start with vote of thanks, sir.
Okay, please proceed.
So with this, we successfully came to the end of this webinar that is delivered by Professor L.D. Patel, sir. Sir, it was really a very good webinar. And first of all, I should wholeheartedly appreciate you for the efforts that you have taken, because by looking at your slides, it is clearly understandable that the amount of effort that you have kept in, because those slides spoke a lot of volume about your preparation. And I think for a person at your juncture, I think there is absolutely no need for you to go through all these efforts and prepare such a worthy presentation. Even though if somebody misses your presentation, if they look at your slides, I think they can understand it by the very own image that they get. And that is highly, highly appreciated of you, because I think it sets a great example when people who are I'm sorry if I'm using this word, but people who are about after their retirement age, if they're working so much for the enlightenment of others, that gives a really high spirit for the people who are currently working. And you set a great example in that way also, not just the biostatistics part, but also in that part where the efforts that you have kept forward. And we are really, I think happy is a very small word for everybody of us. We are really you may add whatever the adjective it is for happy, blessed, or whatever. So thank you so much. And as you said, we will be really looking forward for you for any kind of help that we require while we do our research, and for any kind of data that we have and we are unable to process it. I think we will definitely come to you and have your help in that way. And we'll also be looking forward for you to multiple times so that we can be associated, so that we can. So this time you gave a very elaborate information. So next time we'll go one by one, like something like that, depending upon your feasibility. And once again, on behalf of Chebro Lohanmaya Institute of Pharmaceutical Sciences, we thank you for all the things that you have done these 2 days. Thank you so much, sir.
Thank you. Thank you for your appreciation words. I'm open to you. I'm open to principal sir also. Similarly, like biostatistics, I have so many presentation on NDDS also. So we may have a series of NDDS, starting with GRDDS, gastrodetective, to the pulmonary. So this pandemic time given a chance to prepare everything and to update it, sir. So
Sure,
thank
sir,
you.
sure.
And it's as a teacher, it's duty, Kalyan. It's a duty that we have to imbibe the seeds.
Yes, sir.
We have
Yes,
to
sir.
imbibe. Age is not the bar.
Yes, sir.
I'm totally healthy. My BP is normal. My weight is normal. Height is normal. Everything. No diabetics. Nothing else. And for every 6 months, sir, every 6 months, medical examinations. And daily in the morning, at least 5 to 6 kilometer walking. And in 15 minutes, deep breathing.
That's
that
really
kept
good.
me alive. That kept me alive for our students. And active also.
That's great words, sir. Thank you.
Sir. Thank you.
Okay, so I would like to propose this vote of thanks.
Okay.
So I'd like to propose the vote of thanks. And as a closing remark for this webinar, at the outset, as I previously said, great thanks to Professor L.D. Patil for taking all his efforts and his time so that he can educate all the members of this pharmacy profession in understanding the basics of biostatistics so that they can be implemented in a better way. Thank you so much, sir. And we are always looking forward for yours. Next, I would like to thank the management of Chebro Lohanmaya Institute of Pharmaceutical Sciences for giving us this opportunity to conduct this series of webinars so that the entire pharmacy profession can be benefited out of these lectures. Next, I thank and also congratulate our principal, Dr. S. Vidyadhara, for not only selecting the right topic at the right time, but also bringing the right person for this topic. So I thank him for constantly encouraging all the staff members to go ahead with this. Next, I thank the Department of Pharmaceutics for making all the efforts for this webinar be possible. And I also thank the technical team, which is headed by Mr. A. Chakravarti, for the registrations for this platform and for this program going in air. And last but not the least, all the participants and the staff and non-teaching staff of Chebro Lohanmaya Institute of Pharmaceutical Sciences for their active participation. Thank you. And we'll be meeting once again on a very rightful occasion. Thank you.
Thank you, sir. Thank you. Okay, we are meeting, sir. I'm leaving, sir.